Hey there everybody, welcome back to another video for this Python Pygame series. This video making the Pipes Flowy game. In the last video we put together the main game object in Python. We also loaded in the dictionaries for the various different images of the pipes as well as the water flow animations. And then we did a small test just to make sure that all the images did reflect on the screen. What we're going to do in this video is I think we're going to start building on the main game logic itself, and we'll see where it goes. So I'm just going to close this game here and let's get started. Okay, let's go to the view, appearance, let's make a presentation mode, that's it. Alright, so here in our classes section, underneath the game class, but above my constants variables, we're going to include a new class. We're going to define a new class called PipeGameplay. Straightforward object that we're going to create here. I'm going to give it an init method. Define init. Don't have any arguments for it. First, we're going to go with self.rows. It's going to be equal to rows. Okay, that's a variable that we have not created yet. And self.cols is going to be equal to columns. All right, let's quickly define those variables. Those variables are I've got them saved here. There you go. It's pretty straightforward. Rows is going to be equal to, oh, that's not going to help. Rows will be equal to 12, and columns will be equal to 12 as well. Okay, so we're going back to our pub.gameplay init method, right? Self.columns. Okay, we're then going to go with a self.grid. So we're going to create a matrix, a grid for our game. So I'm going to leave it as an empty list at the moment, because we're going to create the grid through a method. We're going to define that method in a moment. Perhaps it'll be best if we do it now. So let's create that method now. Okay. So let's just go into the class, define method. I'm going to start it with an underscore because we want this to be within the class only. Create game grid. Okay, we're not going to pass it any arguments, it's just using the attributes of the class itself. Let's give it a little comment. Creates an empty game grid per the number of rows and columns. Alright, so we've got our grid, it's going to be equal to an empty list, and then straightforward we're going to say for row in range self.rows. Then we're going to say line is equal to an empty list. Then for column in range self.columns. Self.cols. Come on. Alright, we're going to say line.append. And it's going to be an empty space that we're going to append to that spot. Okay, and then once it's gone through each column in the line, we're then going to say to the grid, the empty grid list, we're going to append that entire line. Right, and once that's done, we're just going to return the grid itself. Right, so coming back to my class PipeGameplay, self.grid, we're then going to call this method self._createGameGrid. Right, fairly straightforward. That creates us a game grid, a matrix of rows and columns that we are going to be using for our game. Okay. The next thing we're going to create under that grid, under the matrix, we're going to create ourselves a self.pieces dictionary. Right? It's going to be an empty dictionary for now. Basically, this is where all the pieces, as they get generated into the game, they will be saved under this dictionary. All right. So once we've got self.pieces, just excuse me for a second. Right, what we're going to do is once we've got the self.pieces dictionary and we've got our grid running, we actually need to insert our starting piece. Let's insert the starting pipe. So to do that, we're going to create a method that's going to insert our starting piece. So we're going to create a method called insertStartPiece. And again, I'm starting it with an underscore because this must only happen within this class. So the self.insertStartPiece method goes as follows. I'm going to come down below my createGameGrid. And we're going to define insert start piece. Right? Oh, what am I doing? Insert start piece. No, that's correct. That's not. There's no underscore there. Okay. So define insert start piece. And we're going to put in a little descriptor. It's going to say randomly select, as soon as we are able to spell correctly, randomly select a starting piece, then insert it into the grid in a valid position. Yeah. Right. In order to do that, we're going to define a variable first. We're going to say with start, it's going to be equal to choice list. Our start dictionary that we created earlier, remember? In the previous video, dot keys, because we want to get a list of these keys from the dictionary. Alright. I don't think we've imported the choice from random. No, we haven't. So right at the top, we're going to go back to there. We're going to do an import. So we're going to say from random import choice. Straightforward. We only want to get the choice function out of random. We don't need to import the entire random module. Okay. Go back down to my insert start piece. So we have start is equal to choice of the list of the start.keys. So here's my start dictionary. There's my start dictionary. There's all the keys of my start dictionary. So start keys provides you like a printable list of the keys, but it's not a list. So I convert all those keys into a list, and then from the list I randomly select one of these 4 items as my starting piece. I'm just going to change my variable name slightly just to make it easier for us. So the start piece has been selected. Then we're going to say valid start position is going to be equal to false, right? And then we also have our row and column is equal to 0, 0. All right. So that's basically the top left-hand corner of our game grid. Okay. So while not valid start position, so while our valid start position is equal to false, right? Row column is going to be equal to rand int. Again, that's another method from the random module that we need to import. Rand int. Okay. So we just have to include that rand int import from the random module. So rand int 0, so the 0 point, self.rows -1. Okay. And then my column is also going to be the exact same thing. Rand int 0, self.columns -1. Right. So now we've come up with a random position on our grid, our matrix, row and column. So you can randomly pick 3, 3 or 3, 2 or 2, 4 or whatever. Okay. So once it's randomly selected our row column, we need to then verify that that position in the grid is a valid spot. To do that, we're going to create another method, and it's going to go like this. We're going to say valid start pos variable, right? So basically this valid start pos variable that we created, it's already set to false. What they're going to say is equal to self._verify start. Let's just call it like that, make it easier. And then we're going to take our start piece, because we need to know the piece, if it's facing left, if it's facing right, if it's facing up or facing down. Right, we're going to take self.rows You see now I'm typing this in straight in from my code that I've already written previously. Let's just go define the function for verifyStart. So we're going to say define underscore verifyStart. It's going to take self, my verifyStart function. We're going to use starting piece. We need the rows, we need the number of columns, we need the row that we're checking, and we need the column that we're checking. All right. And in order to do that, okay, so we're going to give it a little descriptor for this. We're going to say verify the starting location randomly selected. Okay. And this is straightforward, just a bunch of if checks. So we're going to say, well, if the start piece is equal to SRight, right, okay, and column does not equal, if col does not equal cols minus 1, then it needs to return true. Okay. Then we're going to say, well, if start piece is equal to S left and col does not equal 0, you can return true. Once again, I'm going to say if start piece is equal to start up and row does not equal 0, right? Return true. If start piece is equal to S, come on, S down, and row does not equal rows minus 1. And we're going to return true once again. Otherwise, we're going to return false. All right. So what this function is doing, this method is doing, is it's taking our start piece, which we selected here as a random start. So say if it's S up or S down, remember these are our starting pipes. So say if it's S right. So now if the start piece is equal to S right, okay, that's the first part of this check done. And then if the column is equal to cols minus 1, so that basically says if our columns isn't 12, which it is currently, if our column that was randomly selected is equal to 11, and our cols minus 1 is equal to 11, or if it does not equal that. So if this column is 10 and it does not equal 11, which it doesn't, it will return true. So basically we break out of this method, this if check already, we return true. And once we have returned true, the valid start pos then switches to true, and then therefore this while loop will not, once it's gone through its code, will not recycle again. So straightforward, just a very easy little check that we put in place to make sure that our starting position pipe gets put into a valid position. All right. So we've added arguments to our define verify start. So we need to firstly put in the start piece. So that's easy enough, start piece. Then we're going to go with rows, and the rows is self.rows, self.cols. Then we've got row and col. That's easy enough, straightforward. All right. We've completed that check. We break out of the while loop, right? Then we go down to self.pieces. Right, so now our dictionary of pieces at the top here, our self.pieces, we need to actually add our starting piece to that pieces dictionary. So the pieces dictionary, the keys for the dictionary for the pieces, the keys are going to be the grid coordinates of the piece. All right. So that means that self.pieces, we're going to use the row and we're going to use the column. So that's our grid coordinates of the starting piece. And that is actually going to be a new class that we need to create, a new object, it's going to be a new object called StartPiece. Okay, so we're going to go ahead and create our StartPiece object. I think now is a good time as any to do it. Right at the bottom, just above our constant variables, we're going to define a new class called StartPiece. Okay, we're going to define its init method, define init, and when we initialize it, we need to pass it a few arguments. We're going to give it the game argument, which is our game logic. We're going to give it the piece information, so it'll know what starting piece it is. We're going to give it its row and column coordinates. We're also going to pass the X offset and Y offset of the image so that it gets drawn onto the screen in the correct position. All right. The attributes are straightforward. Self.game will be equal to game. Self.piece will be equal to piece. Self.row will be equal to row. Self.column will be equal to column. Okay. Self.x position will be equal to the x offset plus self.col multiplied by cell size. Alright, so there's a variable we haven't defined as yet. The cell size is basically just the size of each square. In my constants variables, let's just quickly add that. Cell size is equal to 64. Because we already know our image sizes, we want to be 64 by 64. Therefore, my cell size is also going to be 64. It's a bit redundant, I don't actually need to put that in, but let's just do it for brevity's sake. Okay, we are busy creating our StartPiece class. We've got our X position, so now we're going to put in our self.y pos, and that's going to be equal to our y offset plus self.row multiplied by cell size. Okay. Let me just have a look quickly. While we're looking at this. Great, so we're creating our StartPiece. We've given it the starting X position and we've given it the starting Y position. The next thing we're going to give it is, remember when we created the start position, it's a dictionary. But this load images returns a list of images. So we want to actually always be able to refer to a particular image in that list, because the starting pipe flow has a starting empty image with just the pipe, and then the water fills up with water. So we're going to create an attribute called self.imageIndex. Nothing fancy, straightforward, and that's equal to 0. All right. So the image that we actually need to draw for this class is going to be self.image, and that's going to be equal to our start dictionary, right? Self.piece, all right, and then so the self.piece will be either S right, S left, up, or S down, and then from that it will return a dictionary, and then we want a particular image from that dictionary, so we're going to say self.imageIndex. Fantastic. Now we've got an image referred to for our starting pipe. Then we just have to go ahead quickly and get the rectangle for that image. So we're going to self.image.getRect, right? But at the same time, we're going to give it coordinates for its top left of the image. For the rectangle, we'll call it self.xpos because we've calculated it just 2 lines up. Self.ypos. Great. We've done that. We just need to go ahead and create a couple methods for this starting piece class. I'm going to define an update method. We're not going to give it anything in the moment. We're just going to say pass. All right. There's a bunch of work that needs to go into that method, but we're not going to do it right now. Then the next thing we're going to create as a to-do portion for later, we're going to say define. No, let's just stick to where we are now. So we're going to define a draw method, and we need to pass it an argument. We're going to pass it the window argument, right? I'm going to say window.blit self.image and self.rect. Straightforward, nothing fancy. There is our starting piece class. So let's go back up to our game logic class. Here we insert our starting piece method. Let's go back to that method. Here was where under our self.pieces, we've now including into our self.pieces dictionary starting piece. Now we need to pass that starting piece a couple of arguments, and as you can see, we need to pass it the game, which was the game logic. I just want to get myself in the right position here so I can refer to the right stuff. Where are we? We are over here. There we go. So start piece, we're going to pass it the self argument because we want the game logic to be passed to the starting piece. Once we've done that, we're going to pass the starting piece. Then we're going to pass the row and the column. Then we're going to give the X offset and Y offset variables, which I'm sure you're aware we haven't created as yet. So the X and Y offsets. So let's go down to our constants under cell size. We're going to create a new variable, and we're going to call it X offset, and that's going to be equal to 128, and the Y offset is going to be equal to 64. All right. So if you just give me a second, I just want to double check quickly where we are. Insert starting piece. We've got our inserting started piece. It's been included into our self.pieces dictionary. So okay, so we're creating our first starting piece, and we are already, don't do that. We are including it into our self.pieces dictionary, which you will notice over there. We're still not drawing that to the screen anyway, but we will get to it. Under my verifyStart, no, go back to insertStartPiece. So once we've done that, we've added that piece to our dictionary. We then need to go to our grid, our actual grid itself, and we also need to include that piece there too. So self.grid, first brackets is going to be the row, second brackets is going to be the column, right? And that is going to be equal to self.pieces, which is my dictionary, and row column is the key that we're referring to, which is the piece that we just created right now, dot piece. Oh my goodness. No. Take that off. Dot piece. Okay. So all we're doing right now is we're going to our grid, and we're finding that position on the rows and that position in the columns, and we are then changing that grid position from a blank line, a space, to whatever the piece is according to our pipes. In this case, it'll be a starting piece, starting up, starting right, starting down, starting left, or starting, like that. So once that's done, we're going to then just return out of this method. Okay, that was our insertStartPiece method right there. Okay. I just want to go ahead and test this very quickly. And in order to test this, we're going to create, I think, a draw method. Yeah. So underneath my verifyStart, we're going to go define a draw method self, and I think we need to pass it a window argument as well because it's coming from the main game loop. Okay, so define draw, and inside that draw method, we're just going to go with, so for each piece in self.pieces.values. All right, piece.draw, and pass it the argument, the window argument. Okay, draw. We still need to call this draw method. So in order to call the draw method for the game logic class, we need to go to our actual game. Right, so let's go up to our game class. Over here in our main game class, we've got PipeGame.display. So here we are in the main game class. Come down to my draw method. Here, right above PipeGame.display update, we're just going to go with, that's not going to help. We still actually need to call this class. We're not creating this class either. That's not helpful. Go to our game class in our init method underneath self.run. Is equal to true. No, not underneath that. Let's do it underneath PipeGame.display.setCaption. We're going to say self.gameplay. Gameplay will be equal to PipeGameplay. Remember, we're not passing any arguments. So that's initializing the gameplay class. And then back down to our draw method, we're then going to say self.gameplay.draw. And we're going to pass it self.screen as the window. Okay, if we run this, let's see what happens. We have an error firstly, colon rain. Oh, that should be range, line 103. Oopsie, that should be range. Let's try run it now. That deserves a clap. Right, so as you can see, we've got our pipe piece in the middle of the field. It's obviously the starting piece up. If I close this and I run it one more time, it should pop up at a different spot. And it's a pipe facing down, and that's our starting piece. That's fantastic. So we need to carry on. There's a lot more work we need to do in our game logic class as well. The PipeGameplay class. In our init method, we still need to insert the ending piece. But I think I'm going to call it quits on this video right here. We've already done 25 minutes. And yeah, I think that's the best spot to stop. If you guys have enjoyed this video, if you enjoy these projects that I'm doing, if you have any hints or suggestions, if you have any tips or comments or anything you think that could help improve my coding as well as improve these videos, please leave a comment down in the comment section below. Otherwise, really, if you guys could hit the like button, if you could subscribe to my channel, I'd really appreciate it. It's great to know if there's actually some people watching these things, and it provides me with more motivation to carry on making these videos as well as these projects beyond just my own hobby as it is at the moment. All right, so great. Thanks for following me on this ride, and I'll see you guys in the next video. Cheers for now.